Good morning, Batch 12. Welcome to CHI Online Training. The subject for today is Electric and Electronics Fundamentals 3 or EEF3. Our lesson is all about RL circuits. So let's start. So first we're going to define what is RL circuit. What is RL circuit? So it says here on the board that RL is a resistor, inductor circuit, or RL filter, or RL network. Is an electric circuit composed of resistors and inductors driven by a voltage or current source. So this is a circuit of RL. Okay. So this is called series RL circuit. Why it is series? Because the resistor is connected to RL and RL is connected to this terminal here is connected to the source. This is the source here. Okay. This is the source. And the other end or terminal of the resistor is connected to the source. Okay. So they call this one series RL circuit. And the other one we have here a circuit which is parallel. This is RL circuit, and this is named or called parallel RL circuit. Okay, so these two circuit is different. Okay, series and parallel are different. Okay, but they are using resistor and inductor. Here, resistor, inductor. So this two terminal of R is directly connected to the source. And also, the two terminal of the inductor is directly connected to the source. So both resistor and inductor is connected in parallel, directly connected to the source. Okay? So now, where to use RL circuits? So RL circuits, there are so many use of RL circuit, but they are commonly used in chokes of luminescent tubes. In an AC circuit, inductor helps in reducing voltage without the loss of energy. So what do you mean by choke? So choke is, or chokes is a coil of wire like this. That is a coil of wire, or they call this one inductor. Okay. Now what is the purpose of the choke? Chokes. What is the purpose of chokes? So the purpose of chokes, of the choke, is to provide a very high voltage initially between the filaments across the two ends of the tube light. Again, once the gas in the tube is ionized, the choke provides a low voltage. Okay, so that is the purpose of a choke. Provide a very high voltage. Okay, and once the tube, okay, or the gas in the tube ionized, then the choke provides a low voltage. So, okay, this is the purpose of a choke. Now, if you combine the resistor and the inductor, this will create or produce or provide an inductance. This will provide an impedance. Okay? An impedance. Okay, so impedance. Remember, if there is inductor and resistor combined with a source of AC voltage, this two combination of resistor and inductor can create or provide impedance. Now, an impedance, the impedance of an RL circuit is the total opposition to AC current flow caused by the resistor and the reactance of the inductor, or XL. Okay. So remember, if there is resistor and inductor, or you have to change the inductance of the inductor to make it inductive reactance. So these two will provide or produce or create impedance. Okay? Now, how to compute the impedance? How to solve impedance? If we have here the circuit, this is the impedance here. This is the two component, the resistor and the inductor. So the inductance of this will be changed or convert to XL, or inductive reactance. So how to compute the impedance? So this is the formula. First, you're going to solve for XL. This is the formula of XL. Inductive reactance is equal to 2 times pi times F times L. Okay? And then, after you solve for the inductive reactance, you can now solve for the impedance. So this is the formula of impedance, which is Z. This is the symbol of impedance. Z is equal to the square root of XL squared plus R squared, where Z is the total impedance in ohms, XL is the inductive reactance in ohms, and R is the resistance in ohms. Okay, so let's have an example problem. Okay, in a series RL circuit, R is equal to 100 ohm and L is equal to 400 millihenry. What is the total impedance of this circuit? So, what is Z? Okay, with a given circuit, okay, series RL circuit, we have the source voltage, which is equal to 10 volts, and the frequency F is equal to 60 Hertz. Okay, so let's solve for XL. Let's solve for XL, and then after that, we will solve for the impedance, the Z. Solution. So, solve for XL. Substitute the value of pi, which is 3.1415. Substitute the value of F, which is 60 Hertz. And substitute the value of L. L is 400 millihenry, but we will not write 400 millihenry. We will convert first to Henry. Okay? So, this will become the 400 millihenry divided by 1,000. Why 1,000? Because milli has 3 zeros, which means 1,000. So you have to divide millihenry to Henry. Okay? So this is equivalent to 0.4 Henry. Okay? So you write this one here. Okay? So what is now the equivalent of XL? So XL now will be equal to 150.7 ohms. Then after that, we can now solve for the impedance. So the impedance is Z is equal to 150.7 squared plus R is 100 ohm squared. Then square root. What is the square root of this? Okay, so your impedance now will be equal to 180.8 ohms. So this is how you compute the impedance of the RL or the series RL circuit. Now, what if we are going to solve for the voltage of the resistor and the voltage of the inductor? Okay, so apply now the Ohm's law to solve for the voltage and the current. Okay, so the same problem or circuit. Okay, but we are going to solve for the voltage of the resistor and the voltage of the inductor. So before we solve for the voltage, we will solve first the total current. Okay, this is the formula. Solution. So total current is equal to the source voltage divided by the Z. So substitute the value of Vs, this one, 10 volts divided by Z, which is 150.7. It's 180.8. Okay, so this is the impedance. So your total current is equal to 0.055 ampere. Then we can solve for the voltage of the resistor. Okay, so this is the formula. Resistor voltage is equal to total current, which is this one, times the resistor. The value of resistor is 100 ohms. Okay, so IT is 0.055 times 100 ohms. Your VR is equal to 5.5 volts. So this one here is equal to 5.5 volts. Okay, then next, what is the value of VL? So inductor voltage is equal to total current times XL. So substitute IT, which is this one, substitute XL, which is equal to 150.7. Okay, so this is now the equivalent of IT and XL. Okay, so 0.055 times 150.7, your inductor voltage is equal to 8.3 volts. Now, is this correct? Is VR correct? Is VL correct? I don't know. So what is the formula to solve for these two? To make it equivalent to 10 volts. Okay. So this is the formula. The square root of total voltage is equal to the square root of VR squared plus VL squared. Then substitute the value of VR, which is 5.5. Substitute the value of VL, which is 8.3 volts. Okay. So your total voltage now is equal to total voltage is equal to 9.95 volts. Okay, so 9.95 volts. See, which is equal to the source voltage. Okay, so this one, your total voltage should be equal to the source voltage. So this is 9.95, which is equal to 10 volts. Okay, So this one should be equal. Okay? If not equal, there are something wrong in the total current or in the inductive reactance or here in the VR or here in the VL. Okay? So make sure that VT should be equal to the source voltage. Okay? Then let's proceed to the parallel. Okay? So parallel. So the impedance of RL circuit is the total opposition to AC current flow caused by the resistor and the reactance of the inductor. Now the equation of the impedance of an RL circuit in parallel. So this is the circuit of parallel. Okay, first you're going to solve for XL, then you can solve for the impedance. Okay, so this is the formula, which is equal to XL times R, that is XL times R divided by or over the square root of XL squared plus R squared. Okay, so this is the formula to solve for the impedance in parallel RL circuit. Okay, so let's have an example. Okay. Okay, by the way, let's discuss about this one. Now, if you make a graph, this is an x-axis, okay, and the y-axis. Okay. Now, here in the vertical axis, that is the inductor, and the horizontal axis is the resistor. Okay. Now, where is the impedance? Here in the center. Okay. And this one is called the phase angle. Phase angle. Phase angle. Okay. So later on we will solve for the phase angle. How? Okay. So with the value of XL and the value of R. Okay. So X and Y axis. Okay, let's have an example. Problem. So the value in a simple parallel RL circuit, the value of your R is equal to 120 ohms and the inductor is 584 millihenry. What is the total impedance of this circuit? Okay, so I will write here the value of resistor, which is 120 ohms, and this one is equal to 584 millihenry. Okay, so this is L, not this one, not XL, this is L. Okay, so this is the inductance of this inductor, 584 millihenry. So we are going to solve for XL. Okay, so XL now is equal to 2 times pi times F times L. So substitute the value of pi, F, and L. So 2 times 3.1415 times 60 times 0.584. How? Why it becomes 0.584? Because here there is milli, so you are going to divide this one by 1000. Okay? And which is equal to 0.584 Henry. Okay, not milli, but Henry. Henry. Okay, and then you write it here. So what is now the value of XL? XL is equal to 220 ohms. So your XL now here is equal to 220 ohms. Okay, then you can now solve for the Z, the impedance. So what is the impedance? substitute the value of XL, which is 220. Substitute the value of R, which is 120 ohms. Then divided by the square root of XL squared plus R squared. Okay? By the way, guys, this one and this one is the same. Okay? I just write it like this so that you will understand. Okay? So, substitute the value of XL times R, the same, this and this is the same. Divide, this is divide. Then the square root of XL squared plus R squared. Okay? So, Z now is equal to 105.3 ohms. So, this is now the impedance of the circuit. Okay, parallel RC circuit. Then, let's solve again the current. The current that flows here in R, which is called IR. And the current that flows here in the inductor, which is called the IL. Okay? And also the total current that flows here, that is called the IT, total current. Okay? So solve. The same problem and circuit, but we are going to solve for the current. Okay? Now, solution. IT is equal to Vs divided by the impedance. Substitute the value of Vs and the impedance. So, 10 divided by 105.3. 10 show up is this one. And the Z is 105. So, now IT is equal to 0.094 ampere. Okay. Now, what is the value of the resistor current? Or current in the resistor? Substitute the value of Vs. That is 10 divided by 120 ohms. Your IR now is equal to 0.083 ampere. Okay? So, the current here, which is IR. Okay? Which is this one. And what is the value of the current here? Let's solve. So, IL is equal to Vs divided by XL. Okay? So, that is 10 divided by 220 ohms. Your IL is equal to 0.045 ampere. Is this correct, guys? So, me, I don't know. So, we have to check if this one is correct or not. Okay? What is the formula? So, this is the formula to check. Our computer is very slow, so we cannot make it fast. Okay? So, this is now the equivalent of the total current. Okay? The square root of IR squared plus IL squared. Okay? So, your total current now is equal to 0.0. What's this? Ibiga, guys. Okay? So, your total current is equal to 0.094 ampere. And which is equal to this total current here. Okay? So, remember guys that total current here should be equal to total current here. Using the square root or the Pythagorean theorem. Okay? The IR squared plus the IL squared. Okay? The square root of IR squared plus IL squared. Okay? So, this is now the total current. Now, how to solve for the angle, phase angle? Okay? If you know the formula to solve for the phase angle, so this is the formula, guys. Your phase angle is equal to, okay, this is the value of the IR and IL. Now, to solve for the phase angle, formula is phase angle or total phase angle is equal to inverse tangent times IL divided by IR. Okay? So, substitute the value of IL, which is this, and substitute the value of IR, which is this. Okay? Then, tangent, inverse tangent, or phase angle is equal to inverse tangent times 0.045 divided by 0.083. So this is equivalent to 28.46 degrees. So the value here is 28.46 degrees. Is this correct, guys? This is correct. Okay? This is correct. Now, if you know the trigonometric functions, you can solve for the IL using this value here. And you can also solve for the impedance using this value here. Okay? And this one, you can solve for the total current. Okay? So if you remember the word sokatuwa, this is the meaning of this is sine is equal to opposite over hypotenuse, and this one is cosine is equal to adjacent over hypotenuse, and this one is tangent is equal to opposite divided by adjacent. Okay? So, if you can use this one, you can solve for the total current here. Okay? So, that's it, guys. That's all for our lesson for today about series and parallel RL circuit. So, see you for the next CHI online training. Thank you, guys, and have a good day.